So you just sat down to design a machine and you are ready to start 3D modeling. However, where do you start? Well, it's a lot easier than you think. For over 12 years, I worked at small and large companies, and I've learned how companies are able to design and make successful products over and over again. So today I'm going to walk you through the 5-step design process that companies use to greatly increase their chances of an idea becoming a successful product. And the good news is that this design process works for everyone, even if you don't have a lot of money to invest, which means that even if you're working on your idea alone, if you follow the 5-step design process, you will be able to turn your idea into a successful machine. Now, I'm excited to share this with you because learning what to focus on next really pushed my design skills to a whole new level. There's always a push to design faster or for less, and many times it feels like the only option is to just jump in and start designing. Now, maybe I can get lucky once or twice, but other times the design just has way too many issues, or sometimes it doesn't even work at all. So once I understood the 5-step design process, it forced me to slow down, to ask more questions, and to stay focused on what's important right now. And ultimately, I can come up with a better design and make less mistakes and finish the design faster. And I want the same results for you as well. Hello friend, and welcome to episode 2 of the Engineers Grow podcast. My name is Andrei Salfetnikov, and today we'll be going over the 5-step design process. So let's jump right in. So step number 1 is research. And this step is very important, and sometimes this is the step that is really tempting to skip and just start going on to the next step. But it's always important to slow down and focus on the research step first. And so what is the research step? And ultimately, the goal is to figure out, is the idea even possible? Sometimes you're not maybe even asking always, how expensive it is, but that's always important. But the biggest question you want to answer, what I want to do, is it even possible at all? So for example, right now, some of you may know, I'm working on a tool changer project that I had another video on earlier. And in this example, let's say Prusa sells a tool changer, the Prusa XL, for $4,000. Now, the problem is that many hobbyists can only afford a $2,000 tool changer. So the question at this step, at the research step, becomes, is it even possible to have a tool changer for $2,000? And so that's the big question. And at this research step, we are going to be focusing on that, answering that question. Is it even possible to get a tool changer for $2,000? So that's just one example. There's many more. Every idea has its own question you need to answer. But at this point, the most important thing to do is to come up with multiple ideas that can work. Sometimes, maybe the first idea you come up with is the best idea, but other times it may not be. So you want to have as many different ideas, at least 3 potential ways to make a machine that fulfills the requirements. For example, in this case, the cost of $2,000. So, when you're coming up with multiple ideas, it might be just, some sketches you drew up, or maybe some very basic CAD model parts. Or if it's like a cost requirement that you're trying to meet, you just can, add up all of the big components and see, can you get even close to your cost target? And so this is what you're trying to do, is you're trying to come up as many of different ideas as possible, see, will it even work? And so as you have a few ideas, then you can just move down the steps and, start figuring out, what are the basic requirements to make the idea successful. So basically what that means is, as you're going to be going on and, going into your, CAD software, whether it's, Fusion 360 or SolidWorks, whatever you use, you want to start figuring out, what do I actually need to design? And so at this step, you want to just start gathering the basic requirements. They don't have to be all fully, fleshed out. They don't have to be perfect. You don't have to have all the details, but you want to capture the big requirements that have a big impact on how you design your machine. And so the other thing is, as you're coming up with different ideas, as you're trying to figure out the requirements, your goal is to be fast and cheap. You don't want to spend a lot of time coming up with maybe a little test. You want to come up with something quick. You want to come up with something you can quickly buy off the shelf. It doesn't have to be pretty. It doesn't have to be neat. Sometimes, you can come up with something on your bench top and it may look horrible, but it's good enough to figure out, does it even work? So at this point, you really don't care much about, when you're testing your ideas out, how neat they look. You just really want to get to the bottom question of, does it work? And so to do that, if you have any parts lying around, use them. If there's anything you can order, buy it. Try to minimize as much as possible designing custom parts that may take weeks or even months to get, because really when you do that, it really slows you down. So kind of just to point out to a few things, once again, what's not important? A clean design is not important. Another thing is a durable, a reliable design is not important at this point. It can be something very crude, just good enough to get you through this first phase, which is the research phase. And sometimes really, and it can be just as simple as for 1 or 2 days while you're testing out the idea. And one example, on the tool changer project is, I had metal dowel pins going into a hot end that had a hole and a slot that were plastic, and those were out pretty quick. And so, but it lasted enough for me to determine, is it even possible to have a tool changer with a single extruder, with the way I came up with it. And so, and that was the most important part. It gave me an answer. In this case, the answer was yes. So I am able to move on to the next step. So now that you are done with the research phase, the next phase or the next step is the concept step. And so the goal of this step is to prove that it's possible to turn your idea into a machine that you can actually produce and sell to a customer. So kind of the key difference is, in the research phase, we just want to know, is it even possible? In the concept phase, we want to get a little deeper into the design and determine, can you actually make that product, make that machine, and then can you sell it to a customer, which for a company means it doesn't just sell it once, but sell it over and over again and make a profit as well. So what's important at the concept steps? Well, there's a number of things. This is kind of a step. There's a lot of things going on, so you do kind of have to juggle things here, but a checklist will really go a long way to kind of stay on track at this step. And honestly, before I get into it, I just want to say that for me personally, the concept step is my favorite step in the design process, because there's a lot of things going on. There's a lot of ideas that you might be working on. You might be, trying out different things, trying to figure out what does it take to make a machine possible, a product possible. And this is really fun, because this is where a lot of the engineering skills get used to take an idea and start putting it into a product that will work. So let's get into the specific things you need to look for and need to accomplish by the end of the concept step. So first is, you are going to continue focusing on the gathering and finalizing the requirements for the machine. So in the research step, we just wanted to gather some basic requirements. Well, now that we're starting to go into the concept phase, as we are working on the design, we need to finalize and write all of the requirements down. Because by the time we're at the end of the concept phase, we need to know all of our requirements, so that when we proceed further down, we know exactly what we need to design. Now, things always change as you go through the detailed design. You might discover new issues, but the goal is to avoid any big unexpected requirement changes so that you don't have to end up scrapping half of your design or a quarter of your design away and have to restart. The goal is that by the time you're done with the concept phase, you don't have a lot of major design changes. You're going to have improvements and fine tuning, but not a lot of big design changes. So at this point, also at the concept phase, it's important to identify all the critical parts for the machine. So you're going to identify all of the, like for example, on a 3D printer, the motors, the guides, the linear rails, the extruder, the hot end, the belts, the bed plate, the electronics board. So those are all of the big critical parts. The chassis, the maybe aluminum extrusions for the frame. So you want to identify all of those parts for your machine. And now that you identify them, you want to start creating what's called a layout of the machine. So basically, you want to know how all of the critical parts fit together. For example, on a 3D printer, how is the frame done? How do the motors mount to the frame? How do the belts route? How are you going to mount your extruder, the hot end? And so you kind of want to start gathering an idea of how everything fits together and how everything will be mounted together. The other thing is you want to determine how all of the main parts will be made. Are you buying some parts off the shelf? So like they're called COTS parts. So like motors and belts, those are probably going to be off the shelf parts that you're buying. What about machine parts? What parts are you going to be machining? So those might be various brackets that you use, maybe to attach your motor, to attach the extruder, the hot end. Are there going to be any sheet metal parts? And what are the sheet metal parts? And which parts are going to be maybe injection molded? Which parts are going to be 3D printed or made additively, as known in the industry? So at this point, you kind of want to determine, how the manufacturing process that you will use to make each of the main parts. And then as you do that, the next logical step is to figure out, well, what materials am I going to make those parts out of? And you want to do that for all of the critical parts at this point. Parts that maybe you need to know, maybe some parts need to be resistant to high temperatures. Maybe some parts need to be strong. Maybe some parts need to, flex. And so different materials work better for different situations. So you have to evaluate the parts, what will the function be, and select the most appropriate material for that part. Also, the next step is, and sometimes it's very tempting to just skip this step and rush to the next step, but you have to do some basic design calculations, some basic FEA if you need to, some to analyze for like the strength of parts, if the parts is going to need to be strong, for thermal requirements, if you're going to have to move heat from one part to another part, such as let's say from a hot end, so it doesn't clog up the hot end, or from the stepper motor, if it's running hot, you want to add a heat sink or something like that. You need to look at all of those things and just make sure that the components you selected and the way you're planning to, let's say for thermal cool parts or for strain, the way you're planning to design those parts, it will actually be possible. Because the last thing you want to do is you don't want to assume that something will work. You can make it out of this material. You can make it, let's say, out of a 3D printed part, and then you get to the end and you find out that's not possible at all. Or you made a big mistake, like, oh, that plate needed to be twice as thick, and it's actually too flexible. And actually, that's one of the recent mistakes I did. So at this point, you just want to make sure you do all of the basic design calculations, so you don't end up in big design changes down the road. Now, the other thing you have to start doing is you have to start estimating the total cost of the machine. And so you don't have to go into all of the small details, all of the small things like screws. But once again, looking through your main components, extrusions, frames, motors, hot ends, extruders for like a 3D printer type machine, So you want to identify those, write down the cost, and calculate what is the total cost of the machine. And so also the next thing that you're doing as you're answering all of these questions and as you're doing all the calculations, you're beginning to design the machine. And so you want to get an assembly going. You want to have design all of the parts. And the critical thing at this point is you don't have to do all of the details. You just want to do the most important geometries. Like you want to know how the parts will look, how they will mount with each other. You want to know, are you going to be mounting them, with screws or maybe with rivets or maybe with, snaps, whatever you're selecting. You want to have all of those modeled in close enough so that you understand what's going on and to confirm that the way you're planning to arrange everything is going to work. Now, you don't need to have all the screws in at this point. Oftentimes at this step, I don't even put screws in just because, it takes time to put them in and just put in the hole for where a screw needs to go. And that's typically good enough at this design phase, the concept phase. And a couple more things, but, we're at this point, we're coming up towards the end of the concept phases. One is you need to do some basic prototypes and some testing to make sure the machine will work like you expect it to be working. So these prototypes, they don't have to be expensive. Sometimes it's simple as some paper and cardboard cutouts that you do just to make sure parts will roughly fit together right. You want to do things like you want to make sure that you can actually assemble the machine. So with, let's say, a paper mock-up that you put together, you kind of want to make sure, can you get all the fingers in where you need to get them in to access all the parts and the screws? You are looking for those kind of things. You're looking at, can I actually easily assemble the parts together? And so sometimes it may be a paper mock-up. Sometimes you might use more advanced, actual parts. Sometimes maybe it's just 3D printed parts. Just doing 3D printed parts for parts that will be metal down the road goes a long way, just to make sure everything fits together the way you think it will fit. Everything will assemble the way you will assemble. And sometimes you just find out you missed some big assumption, missed a few big things about how they work, or maybe you completely forgot about a feature that you need to put in. So doing parts tests like that goes a long way. And once again, the goal is to do it quick and cheap with these prototypes. Unless you have to, don't use, the final parts. Don't machine a part out of metal that's going to take 8 weeks to arrive if you don't actually need it. If you do need the strength to find out, does this machine work? Yeah, then make the part the way it needs to be. But if it's just more of a fit check, an assembly check, then you can use quicker tools like even 3D printing or paper mock-ups. So that's in regards to prototypes. And then the other thing you're looking at is, at this point, I want to identify all of the long lead items. So long lead, what does that mean? That means typically, at least in my world, anything that takes 8, 10, 12 weeks or longer. Pretty much anything, 8, 10 weeks. Sometimes I've seen parts, 16, 20 weeks, occasionally longer. You want to identify those and order those earlier. Sometimes you will even order it at this phase, just because once they come in, the rest of the design will be ready to be made as well. So the last thing you want to do is you don't want to order it when you order all the other parts, and then all the other parts arrive on week 8, but you have to wait another 8 weeks for the long lead items, and you can't finish assembling because of that. So to prevent that, you order the long lead items earlier, and that's why it's important to do that at this point. I kind of really hate this step. I hate doing it because I like to be done with the design before I order all the parts, but when it comes to long lead items, you just can't avoid it. So you focus on working on them earlier. You try to design them in a way where it gives you flexibility down the road if you have to change the design around, and then you order them and you design everything else around it. So that's how it works. There's not much you can do to get around it. The other thing, I guess, last final thing I can say is, I kind of mentioned it, but it's important to understand the assembly flow of the machine at this point. And it's important to, if there's any types of calibrations or testing that you, as you're designing, you will allow production to produce this machine. Because it's one thing for us engineers just to take our parts, we know how they're supposed to work, and we're going to probably be careful, assemble and put them together. But it's completely another thing to hand that off over to production, where you have technicians that maybe are not as familiar with the design at first, at least, or they have their quotas to meet. They have to make X amount of machines per hour or per day or per week, and the easier you can make it for them to assemble, the better it is, and the better your design is, and the less it will cost. And so it's important not to skip this step, especially for catching things like you can't assemble something because something is missing or something is in the way. So you want to make sure you start looking at that. I personally like to, oftentimes, we have a separate engineering team that works on production and making sure our production process is good. So I like to get involved with those engineers and with the actual technicians that will be assembling the machine or assembling some parts, or using, like if I'm designing a tooling fixture or tooling assembly, invite the technicians and the manufacturing engineers to review it and teach me on what's really important. Because sometimes, they do this every day and I don't understand all of what it takes to build a machine. So having their input at this point is very, very important. So it's easier to, sometimes we can have this tendency and a mentality to say, well, I designed it. It's your job to figure out how to build it. I'm going to design to make it good. I know it's going to meet all of my requirements. It's your job to figure out how you're going to make it. Well, that's not a great way to make a product, and it'll cause more issues down the road, not just for the manufacturing floor, but for you as well, because then you'll have to go back and address it. So at this point, just take that step. If you're in a company, work and ask the questions from the manufacturing engineers, from technicians. If you're working on an idea alone and you're like, I don't have anybody to go to ask, well, kind of like on this tool changer that I'm working on, I'm working on this alone at this point. And so in this situation, just, slow down and then put your technician hat on and ask yourself, well, if I was to assemble this, how hard is it? Can I easily assemble it? Or am I going to be frustrated trying to do this or that? And just learn to switch between a designer role and a technician role. And doing that kind of a thinking will help you look at the assembly process as well. So that wraps up the concept phase. There's a lot. I know there's a lot of things you have to consider. And it also what makes this step the most fun and important and enjoyable for me, because a lot goes on here. There's a lot of design changes, a lot of great ideas that you're battling with and working through. And then sometimes you come up with a really great product. Sometimes you go through multiple iterations. You can go through 5, 10, sometimes more design ideas with that, big changes from what you originally thought. Because in this phase, a lot of things are changing as you're learning about what you need to do. So it's a fun stage, but after the concept phase, the next step is the detailed phase. But before we get there, let me know if you have any questions. Does this make sense so far? If you have any questions, let me know. And let me know what stood out to you. I'd love to know how this has been helpful to you. So now we're done with concept phase. Step number 2, we're ready to move on to step number 3, which is the detailed phase. Well, at the detailed phase, things really start picking up. And pretty much we take everything we've been doing at the concept phase, and we're going to be focusing on a lot of that. But now we have a different goal. At the detailed phase, the goal is to finish the design so that you can start building your product, the machine you're building and designing. So once again, you go through a lot of the stuff you already went through the concept phase, and then you really start cleaning everything up. So kind of the big view picture is by the time you're done with the detailed design, the models that you started with that were very rough and just good enough to see where you're at, you're going to finish those up, and those are going to be complete models. You're going to create drawings for vendors so that they can start making the parts for you. Also, you start out with rough models, but now you're going to optimize the design. You're going to be looking at a lot of different things as you're going through the design. You're going to be looking at the cost of each individual part. You're going to be looking at how do I minimize the number of parts I have? Because often what happens is, you figure out a way to make a machine work, and it has a lot of parts maybe. But then as you start thinking about it, I'm like, oh man, this is going to be getting too expensive, or it's going to be a lot of different parts to assemble, or maybe you have to assemble from many different directions. So at this point, it's important to start thinking about how can I reduce the number of parts? Maybe if I have like a little sub-assembly and it's made from 5 parts, can I reduce it to 4? Or maybe can I reduce it to 3 parts? And small improvements like that go a long way in production and to make a product more successful. But the thing is, it takes time to go through all of those. And so at this point, you will start noticing that the design is changing maybe slower in some sense, because in the concept phase, there was a lot of different things that were brought up, a lot of different things tried. Now you're finalizing the details, and it seems like you should be able to reduce parts quickly, but sometimes getting the parts reduced, the number of parts reduced, or just simplifying how a part works takes a lot more time than just coming up with the original design. But that is very important to do at this point. The other thing that it's really important to focus on at this point, especially if you have weight requirements, is to minimize the weight of the different parts and the different components. And sometimes it's not important. Often when you're working on different tooling fixtures, test stations, weight is rarely a critical requirement. So then it's not important. But when you're designing a machine, usually weight is a big factor that you have to look at. And so this is a point where you really start looking through each part and minimizing the weight so that the whole machine is as light as possible, which usually is the goal. Also, in the concept phase, you probably started doing some basic calculations, some basic FEA. Well, at this point, you're refining your calculations, you're refining your FEA, you're going in more detailed, you're redoing it once you have the final part designed. And so it's important to take what you had and progress it along so you get a much better answer on the final design of if the design and the decisions you made will work or not. Also, at this step, it's important to go through and do any follow-up prototypes, any follow-up testing. Earlier on, it might have been like maybe paper mock-ups. It might have been quick parts you quickly put together in the garage or in the shop with some tools you had. Maybe it was sheets of sheet metal you had, whatever you did. Well, now it's important to do additional testing, and sometimes you're even willing to wait for a few weeks to get a part. At this point, you might be willing to pay higher price for a part to get it quicker, such through vendors like Protolabs or whatever. They can be quick, but they can also be more expensive than your production version of the parts. But you want to make sure that the critical parts, the critical functions work like you expect it. Basically, you want to make sure that you have the confidence that when you're done designing and when all of the parts arrive, the machine will work. It won't be perfect. It almost never is, but there's no such big design flaw that you have to scrap the design and start over again. Pretty much with all of the testing, you're trying to avoid that situation. And so that's pretty much it with the detailed design. Is you're taking what you made at the concept phase and you're refining it and getting it done so that you can move on to the next phase, which is step number 4, which is called New Product Introduction phase. But before we do, I wanted to share with you a project that I'm working on that you might be interested in, and that's the single extruder tool changer. And the goal of this project is to come up with a cheaper tool changer that a hobbyist can afford, that they can make themselves, so that they can get a tool changer for a lower cost than what's currently available in the market. But they don't have to settle for a system where they have to swap out filaments with a single extruder and a single hot end. So if that's something that's interesting to you, sign up for the membership waitlist. I'll be launching that sometime soon, and it'll be a place to really dive in and work on the tool changer. There will be a community aspect to it. There will be live call aspect with Q&As. So if that's something that's of interest to you, go ahead and sign up. The link will be in the comments and in the video description below. And so with that, let's move on to phase number 4, which is new product introduction. And at this point, the goal is to take your design, take your machine, and transition it to full production. You want to take it from an idea you had your models done, you had your drawings done, you ordered your parts, but now you need to be able to produce it on the production floor without engineering involvement. And so that's the goal. By the time you're done with the new product introduction phase, the company will be able to make the parts without your involvement as the design engineer. Now, if you're working in a company, this often, a bigger company, there's different groups often and departments that really focus on new product introduction, and you're just working with them. In a smaller company, that might be just you or another person you're working with. But the goal is, regardless, it's the same. You want to make sure that one, your machine works as expected. At this point, you're starting to get your parts in, you're starting to assemble them. One, you're making sure that the machine works, because at the end of the day, it needs to work, and it needs to be producible. So then you look at, make sure that you're actually able to assemble it, that if there's any issues with the assembly process, you start working those out. Oftentimes you might be making small design changes to make it easier as you have technicians start building it. Oftentimes what I've seen, what happens is you design it, you know how everything's working together. When you're putting it together, you're more careful, you're more cautious, you're giving it more attention. But when a technician is starting to build it and they're in a time crunch, they start running into other issues that you did not expect. And this is the time to start resolving those and cleaning up your design for assembly process so that the machine can be built quickly and efficiently down the road. Also, at this point, you have to do extensive testing on your machine. There's many things you want to test at this point, and it really depends on your requirements and how the machine is being used, how many machines are you selling per year or in the whole life of the product. But there's a few different categories that you're testing for. The first and not most obvious is functionality. Does it work like expected? And does it work basically throughout its warranty period and beyond? Because the last thing you want to do is you assemble it, a machine works, but then 2 months down the road, it starts failing, and you have to have warranty claims, and you have to be reworking the machine, bringing it back in. So you want to make sure that it works as expected for the warranty period and beyond. So that's the first part, the functional testing. The other big bucket of testing is often referred to as environmental testing. So things like thermal, for example. If your machine will be in a warmer environment or a cold environment, so you have to start testing for those to make sure that if it's operating at a high temperature or a lower temperature, that it actually still works. You might have some vibration requirements. Maybe your machine will be on some truck or on an airplane, whatever. And in those environments, there's going to be a lot of vibration. So you have to test for vibration. The machine might work great when it's sitting on the floor, but then once it's being used in a mobile environment, does it still work? Let's see what other things, like there might be some electromagnetic radiation that you have to deal with, EMI often referred to. And so it might work great in a lab setting, but then when there's other equipment around and there's all these electrical interferences, does it still work reliably like it's supposed to? So a lot of different testing. It really depends on your requirements, but you want to also check those sets of testing as well. The other thing that's important at this point is really to train and enable the technicians to build the machine without engineering support. We already touched upon it a little bit earlier, but it also goes in deeper on creating work instructions, standardizing the process, standardizing the flow. Oftentimes there's like bill of materials work, so the way you organize your assemblies and sub-assemblies, that becomes important at this point, especially if the machine is more complex. So you're starting to work out all of those details at this point. So based on everything you've done, you might have learned, hey, I need to make this design change, I need to make that design change, I need to make a third design change. This is the time to do it. You don't want to push that out any further than you have to. So at this point, you really want to clean up the design, make sure it's done and complete so that down the road, there's minimum changes. And then the last thing you want to really look at this point, and this is not my favorite one. Nobody likes this one, honestly, from engineers, but setting up the supply chain. And if you're working in a bigger company, you're going to have separate supply chain groups that are helping. But if you're working in a small group or by yourself, you have to start looking at things like who's going to be making what part. Can they make the part reliably over and over and over again? Sometimes you order a part, you get a batch of parts, it works great. And then you submit a second order and then something doesn't go right. Maybe there's a misunderstanding on the drawing. Maybe there was a mistake made somewhere along the way. And so getting parts reliably over and over and over again at the price that's affordable to you is critical, and that takes time. Setting up all of anything else that's related, you might have a special ordering system. So getting all of that cleaned up and ready to go is going to go a long way in making your product a success. And honestly, this is kind of the most surprising thing to me. Little did I know when I was going through the engineering school and starting my career that thinking about supply chain was going to be important, but it is. And like bigger companies, they have whole departments. That's all they do. There's people, buyers, that all they do is they order parts over and over and over again because it takes time and it's that important. Sometimes the buying process is just as important as the machine design itself. So with that, you're wrapping up with phase number 4, which is new product introduction. Once you're done with that, you're ready to move on to the phase number 5, and that is the often referred to as sustaining phase or production phase. And so at this point, the most important goal is to consistently make the machine on time and with consistent quality and within your cost requirements. And so consistency is probably the overarching theme here. You want to have consistency in everything that you do. You want to have flow. You don't want to have any disruptions. And so if you've done your job well, in the previous phases, then sustaining is a lot easier. If you took a lot of shortcuts to try to get to production, then you're going to have more issues down the road in this phase. You might have to have a lot of design changes and things are constantly changing because you took shortcuts. Sometimes you had no choice. You had a deadline to meet. You had to get your product out. There's contracts in place. There may be late fees involved. So it is what it is. But when you do have a chance, if you took all the time that you needed to get everything right in the previous phases, the sustaining phase becomes a lot easier. So what's important at this phase to have consistent product over and over again? Well, one of the things is strict revision control on all parts and all tooling. Because at this point, you have a lot of parts flowing, you have a lot of parts being ordered, you have a lot of parts being assembled. They're coming to the production floor and maybe different kits getting assembled at different points in the process. And so anything that changes has a big impact on everything else. So if you have to change a bracket here, it might also impact all of 5 other components. And you have to coordinate when you change this part. You might also have to coordinate, when you're changing these parts and when you're ordering them as well, so that the right parts arrive together at the right time. You might want to make sure that when you're changing this part, it doesn't impact how part B is performing. That's another big thing that you have to look at. And so whenever at this point in the production phase or the sustaining phase, every single change you make, you have to go through a lot of scrutiny and review to make sure you're not going to have any other major impacts on everything else. And so this is actually becomes very time consuming and very wasteful when you have to change things. So that's why it's important to have a clean design in the previous phases. But if you do have to change something, sometimes you have to change things. There's nothing you can do about it. You have to be very strict. There's PDM, where you can track all the changes, where you can properly release changes to production. And then you have to really work with all of the different departments, supply chain, technicians, and engineering, to make sure everybody's on the same page of what you're doing and why you're doing it. And so at this point, oftentimes when you're making a decision to change something, which is kind of really annoying for us as engineers, but it's the reality of this phase, you're often not looking for the best solution. Most likely, most of the time, you're looking at a solution that makes the least amount of impact to everything else. Sometimes it's a matter of choice. Sometimes you don't have a choice. You can only put on a Band-Aid on your machine and just work with what you have. So that as you're making design changes at this point, you're going to be very restricted with what you can actually do. But that is important at this phase, and that is the reality of this phase. Is once you're in production, this is how it is, and that's what works. And so that's basically it for the sustaining phase. So just a quick overview: 5 design phases. The first is research. Second, concept. Third, detailed design. Fourth, new product introduction. And 5th, sustaining. If you go through those 5 steps in that order, then you will be able to focus on the right thing at the right time, so that your product, your idea that you have, becomes a successful product when you're done. And so that's how you do it. That's how companies do it, big or small. That's the order of things that you need to focus on. And if you do, you can have confidence that when you're done, you will have a machine that works. So with that, if you found this helpful, let me know in the comments below, what designs are you working on right now? I'd love to know. Now, obviously, if there's IP stuff, intellectual property, or things you have to keep confidential, don't share those. But whatever you can share, I'd love to know the type of machines that you're working on. And if you have any questions from anything that we went over below, feel free to comment below, and maybe I'll be able to respond or answer those in a future podcast. With that, have a great day and have fun designing cool machines.